right. Hello, everybody. Welcome back. Hope everyone's having a wonderful day so far. We are here doing some more studying tonight. Another day, another study session. The grind does not cease. Welcome back, everyone. I hope you're having a wonderful day. We are continuing on. Let me go ahead and pull up the. Really not going to show me in my recents here. Ooh, we're going to go all the way back to the beginning on me. Don't do that. There we go. All right. Let's get this set up. A little bit behind schedule here. Sorry, had to run and make some last minute Valentine's pickups. Feel good about what I got, so hopefully we are in the clear this year. I feel good about what I got her for Valentine's Day, so hopefully we win, and we are in the clear. It's always a toss up. You never know. All right. Closing some last minute deals. Hey Mahan, Tim, welcome back. What's going on, you guys? Tim, your memes kill me in the chat. The Kermit one, looking at one. When I not streaming, that one killed me when I saw that one. That was funny. But but I'm sorry, Tim. Okay. So on my vacation I'll have Wi-Fi. So I leave on Saturday. So I'll try to maybe stream. I don't know how early I can on Saturday. If I have time, I'll try to squeeze one in. But I leave on Saturday, and that being said, uh, I'm gonna try my best to feel like I have Wi-Fi, but I just don't know how fast it will be. So if it's slow, then I might just have to record videos and upload videos, just like I'll just record myself programming for an hour straight on the business manager project and upload it, or we'll stream. So I'll still keep content rolling out for you guys, but the stream might have to break. It might have to. It's like a 50-50 shot right now. 50-50 shot right now. So hopefully we can keep the streak alive. So thank you guys for joining me here. All right. This guy. All right, let's do the next problem here. R 9.5 keyed up high. R96 key up high. R97 keyed up high. And then let's do one more R98 keyed up high. All right, let's dive on in here, you guys. Number 5. Let me go ahead and just grab a drink really quick. I don't have my soda tonight. I got to get my soda so we can keep the pep in our step here. All right, hold on. Give me 1 second. I'm gonna grab a drink here. All right. Oh, let me get blanket in here. Come on, get up there. There we go. Oh, jeez. all tied up here. Okay, come on. There we go. There we go. Jeez, sorry guys. Thanks for your patience with me here. We are dysfunctional this evening. Lots of cords everywhere. All right, let's get back to it here. Whew. The cherry Coke. This one today is just regular Coke. I drank all the cherry Coke yesterday. Hey, David, is me. Welcome back. Thanks for coming in. You guys are starting to know me pretty well here. I got the regular cherry Coke. That's funny. Okay, so let's start these problems, guys. Let's get into this. Tim, do not disturb is going on. Okay, the min method for the unsorted priority queue class executes in O of n time as analyzed in table 9.2. Give a simple modification to the class so that the min runs in O of 1 time. Explain any necessary modification to other methods of the class. Oh gosh. Okay, so let's go to the 9.2 example. 9.3 unsorted priority queue. Here, 9.2. All right. Okay. So the unsorted priority queue class that we went over has a function called find min, right? Non-public utility, which if it's empty, raise it's empty. Else we create a small equals to the data first element, and a walk equals to the data after small. While walk is not none, if the element on the walk position is less than the small is equal to that walk position, and we'll call a walk continue to walk down. So this will just evaluate the current smallest. So then in the min function calls that find min, right, and then just returns the elements of that item, right, of that position. So we can modify this class by keeping a minimum. So let's go, we can modify the unsorted priority queue class by keeping a minimum variable slash container as and evaluating as elements are added to the queue. This way, we no longer have to iterate over n and during the underscore find min function evaluating every element in n. Right, so we can modify the unsorted priority queue class by keeping a minimum variable slash container within the class overall, and evaluating as elements are added to the queue. This way, we no longer have to iterate over n during the find min function evaluating every element in n. Evaluating smallest for every element in n. This would completely remove the find min function, and the min function would return the current right p dot element within the smallest class instance variable. Right? Hey, how's it going? We got some chats in here. Hey, Zero, how's it going? Welcome in. I appreciate you for coming in. Thanks for leaving a message here. Awesome. How you doing? Sorry I didn't get to you sooner. Your name's is a little bit new here, so welcome. I just want to say hello to you, and thank you so much for finding the stream here. My name's Michael. Appreciate you for joining me. Hey, Richard, welcome back. All right, not coding alone anymore. Sweet. Yeah, sorry I'm a little late, Richard. The stream is live here, so we can we're working together now. All right. Bro, empty the fridge. Mike, the guy on the team, to show up at an optional practice. Carlos Salcedo, time to hit the books. Let's code. Hey, welcome in, man. It's awesome to hear from you. What are you reading? Are you reading this book along with me here? What are you currently studying? Hey, Zanab, welcome back. Good morning from Pakistan. Good morning to you. Well, it's coming into my evening, so hello to you from Pakistan. Wow, awesome, man. Thanks for coming in. Welcome back to you. I code in Java, and anytime I look at Python syntax, it looks weird since it doesn't have the semicolons at the end. Yeah, some people often tell me that it looks really like blank or like it's incomplete. But because that's kind of all I know, when I go to program in C, it just feels so cluttered. It feels so messy. But when I go to Python, I'm like, it's so readable. It's nice. But so it's the grass is always greener, right? Okay, so let's go ahead and throw this guy in to the almighty orb. Oh, no. Get back here. No, first preface. I am... So, right, remember, if we're going to ask the orb something, we have to, first give it the right prompt, right? So I am trying to solve some of the text problems from DSA in Python. I am on... please don't spoil the answer, but guide me using my current Your understanding is spot on. Oh, okay. Here we go. Your understanding is spot on. Let's refine your thought process or break it down step by step. Key insight, current approach, O of n, min time complexity. The find min method iterates through all elements to find the one with the smallest key. This is why it takes O of n time to get the minimum. The goal of O of 1 min time complexity, we need to maintain the minimum element as a class attribute min element that is always up to date. That way, calling min will simply return the stored value in O of 1 time. How to achieve this? Tracking the minimum during insertion. Add. When adding a new element, compare its key with the current min element. Update min element if the new element is smaller. Handle removal of remove min. This is the tricky part. When removing the minimum, we must update min element since we don't have a stored structure. The easiest way is to recompute it by scanning all elements after removed. Or you could just keep 2 pointers for previous, so if you have to remove min, you have one to back it up. But that means you would have to essentially have the list be sorted because then you'd have to know it again. So yeah, you'd have to iterate either in n again, basically, or that defeats the purpose of being unsorted. Because then if you're sorted, you would, in order to do my approach, then you would have to just have another array that is sorted with the elements. So yeah, cool. So this is we the remove min function would need to would pop the current class minimum element and scan over n to find the second lowest element. Now the new minimum. So even though I was able to get constant time on the referencing, I still have to have linear time taken to refine a new min during the removal. So there is a trade off. Which is tech better? Would we prefer to remove the movement, the remove min was already calling the find min function, right? So I guess it doesn't really matter for that function alone. It remains linear. We just optimized the peak and overall speed. Let's see what it says about that. Oh, we nailed that. Let's go. Good. Yes, you nailed it. Trade-offs of analysis. Before optimization, min runs an O of n because find min iterates through the entire collection. Remove min also runs an O of n because it calls find min before removing the minimum element. After we optimize, we were able to optimize min to O of 1 because we kept a reference to minimum element, but the remove min still runs an O of n because you need to recompute the minimum after the minimum element is removed. Why this optimization still helps. Min is likely called more frequently than remove min, reducing its time complexity to O of 1 improves the overall performance. Remove min doesn't get worse, it stays O of n, so we're not sacrificing anything here. In short, this trade-off makes sense because, yes. Cool. That was a good one. That was fun. When do you plan on doing linear math? I want to start and follow along with you. Soon. Yeah, soon. I will. I don't know if we're gonna be able to do linear math right away. We got some stepping stones to get there in math. I still need to review over quite a bit of my calculus. I took calculus my freshman year of college, so I was like, 18, 19. I'm 26 now, so that was over 7 years ago. So it's been a long time since I took my calculus. I still remember that ladder leaning on the wall problem when if it slid down, like what kind of, I can't remember. We had that discussion a couple weeks ago back in chat. But if you guys remember that calculus problem, shout out to you guys back from Calc 1. I think that's like a universal, everyone knows that one. But yeah, so we need a little bit of refresher. If you guys think linear algebra is, do we need to have that refresher, or will we be okay in using just basic, algebra and pre-calculus to, dive into that? But I will be starting new stuff after we complete Harvard CS50X because I just don't want to stack too many courses on top of everything because I don't want just to overload it and then end up not finishing everything just because we have so much going on. I really want to just take a bite, finish it, and then take another bite, finish it. And so we'll get there soon though. We're almost done with that course. Hopefully by the end of February we'll be through with the CS50X course, or at least working on the final project. So there'll be no more weekly lectures, and then we can move on to a different course. So we'll have to do a poll in the Discord if you guys want to vote on the next course we take live on the stream, whether it be a math course, another programming course, a language, whatever it may be. Join the Discord link below to get access to all my study resources. Thanks so much for joining me, everybody. My name is Michael. I'm 26 years old. I've been teaching myself Python and computer science for about 6 months now. We started with Harvard CS50P, paired that with the Python Crash Course book, and then started building our own projects from there. We started reading next out of the Data Structures and Algorithms book. We're almost to page 400 of live reading on this channel. So really, really crazy that we've come this far, and just grinding through it, example by example, problem by problem, word by word, as funny as that may be. But it really, really has helped, to translate these topics and understand them through the text and then put them into these courses that I'm taking, like CS50. It really, really helps because I'm kind of already familiar with these structures and how to kind of make my way through them. And also I've been able to translate that into a lot of these LEET code and Neet code problems. Like I was able to implement the stack problem, which is a medium, LEET code problem, fairly easy. I was able to create that stack in about, it took me only like 5 minutes just because we were given so many examples of stacks back in chapter, 7, I think it was, or whatnot. 6, 5, I can't remember. So we are making a lot of progress here. You guys, we stream live projects live on the channel. So later this evening, we'll get some more work on our small business manager project that we've been writing live on the channel. We got over 1,000 lines here, just of functions and various menus that we've built to convey, business statistics and track, inventory and expenses. And it's a cool project. So, anyways, let's keep on moving here. Let's go to the next problem. This was my answer for 9-5. Go to 9-6 now. All right, and all these books and notes, everything, you can find the notes on my GitHub, linked below. You can find all the books and everything in my Discord, linked below. I provide everything to you guys completely transparent and free. I really just enjoy, doing this alongside you guys. So thank you truly for joining me here. Sorry about my ramble, but we can now continue on. All right, let's move this here. Ooh. Okay, can you adapt your solution to the previous problem to remove min run in O of 1 time for the unsorted party Q class and explain your answer? Well, it could just do what I said, right? You could, I mean, you could if you just keep pointers of every single one, well, then essentially you're just keeping a sorted array, and then as you're popping elements off, you're just tracking it as well. This kind of runs back to that Neet code problem that we did the other day. This is exactly that almost, where you have kind of a queue, or you can kind of think of it as like almost like a stack, where the if not like a stack because the last elements are popped off first, but because that's kind of what I'm envisioning though, like an array. What I'm saying though is that we can do the detection on add and then create basically a stack for or a sorted one under the hood, and you just keep popping off elements. So I'm not sure exactly. Anybody have some thoughts for this one? I'm gonna go throw this one in here and say I have another. question. Let's work through it. Okay, chill out, bro. Oh, this is getting fun. You're being asked to adapt the previous solution to make remove min run in O of 1. Let's think about it logically. Remove min is O of n because we must find the minimum element in its unsorted list before removing it. The goal is to make it O of 1, right? Okay, so... Okay, why? Hold on. You're going way too far ahead. Okay, what are you doing? No. Stop going ahead. Wait for me to prompt. Come on, man, you're being annoying. No, stop. This is my question. Prompt me for my current understanding. Okay. We know that it is now O of 1 because of the min element, right? Remove min is O of n because after removing the current minimum, you still have to search for the next minimum. Okay, the question is how could you avoid scanning the entire list for the new minimum after removing the current one, right? How could we avoid scanning for the new after the current? What could you compute and track ahead of time to keep track of the minimum? So as items are loaded into the queue, we are already evaluating technically over n. So this is basically a sorting mechanism that is under the hood for this unsorted priority queue. We can create a new list or structure to store a sorted reference to either the element or its index order to pop and use this as our removal feed. Oh! Boom! Okay, exactly. What you're describing is a shadow structure, okay, that keeps track of elements in sorted order without actually sorting the main queue every single time. This allows you to add O of n, since we need to update the sorted reference while adding new elements, min O of 1, because you have the minimum pre-computed, and remove min O of 1 because you can simply remove the minimum from your sorted reference and remove it directly from the queue. What you just achieved, you turn an unsorted queue into a kind of a hybrid structure that mimics the behavior of a sorted queue without needing to search for the minimum during the removal. Woohoo! Okay, can you clean up my answer for something more structured? To adapt the solution so that the remove min runs in O of 1 time, we can introduce an auxiliary structure to track the elements in sorted order. While elements in the main queue remain unsorted, this additional structure will maintain references to the elements in sorted order, either by direct storing the elements or their indices. How it works, right? Okay, perfect. This is a good... Or should I take mine? We'll take the cleaned up one. All right. Yeah, Mahan, the rate of speed. Yeah. Whenever you do whichever math you choose, I'll follow along. Awesome, Bontrell. I can't wait. That's awesome. That sounds great. Which one would you prefer? It sounds like you're leaning towards linear algebra. I'll be with you all the way through the Python crash course. I have to finish it. Nice. Carlos, did you see the recent upload for the Python crash course? Try it yourself. A couple of you guys were, getting on me and chirping at me, saying, we want another video of that. So I felt bad, and I was like, dang, I gotta keep going on those. So I recorded one after work one day, and I edited it last night pretty late in the AM and threw it up. So hopefully that one, it's about, using the sorted function versus the sort method, and then also the reverse method versus the actual keyword, override of those sorted functions to reverse. It's a cool problem. It's a pretty fun little beginner one. So right now you're doing Harvard and Python crash course right now, just those two. Um, and Python courses right now. So the only courses I'm doing right now are the Harvard CS50X course, where we're finishing about on track with about a week every week. That's kind of we're on track with the course. So uh, that's the only official thing. But we are just reading this book that I do want to get through. And I mean we're getting chunked of it through it done here. We got a long ways to go, but um, you know I just feel like I do want to finish this book. It feels so good to get through this, and it'd be a good. We're 400 pages in, but if we need to put it like this on the side, not do as much to also do a little bit of math and get that going as well, we might have to do that too because we definitely need to get math going because we have this guy back here just staring at us. The Python machine learning that we're gonna get into. I just flip through this and I see this kind of notation and I'm like, oh my God, what am I gonna do? Because this does not look very fun. We're gonna have to take this one page by page, boys, page by page. But has anybody read this book? Anybody out there have some feedback on this one? And then I also have down here, right here, you can't see it, but I have the Fluent Python book as well. So we got a lot of content to go here, and we're just still chugging along. So right now you're doing Harvard. Okay, nice. And I checked your GitHub profile and also found the notes. Nice. Tim, I'm running from that guy. I haven't tried it again since we failed. Okay. I think I used that book in my machine learning course. Yeah, maybe we'll have to pair it with a course because maybe that book will be a little bit too dense. The prereq is Calc 3 at my university. Okay. See, we have a little ways to go then, you guys. We need to get through. Do you find the book is equally or more useful than the lessons on YouTube/GPT? Um, GPT is really good to kind of simulate that conversation that you would have with like a TA in college, or like if you would go to office hours or to the graduate students like lab center or whatever. And like for my physics course, I remember I went in to the graduate students had like a little lab area. Part of their duties as graduate students is they had to host office hours in this little physics lab where you could go in there and just get help on your homework and stuff and um, you know just by being able to talk through those problems, that's what I'm kind of mimicking here with the GPT is I'm using it as like a colleague to bounce ideas off of and be like, oh, what about this, what about this, oh no, you don't think that's right, well, what about that, oh, okay, cool, you like that one. And it really helps to kind of also just simulate like a colleague conversation, I guess, along with you guys as well. But like people had said before in yesterday's stream, the books are really good just because they are dense. They provide the material and they provide kind of all of it in a sense. They don't really leave out any things like some videos do, because videos are tailored to try to keep your attention and only provide, the things that are really, super, you know, the most interesting things. And, you know, and not that, yeah, those things are important to learn, but sometimes we do want to learn those more, monotonous and grueling topics, just because we want to get a solid, more, solidified understanding of this, these lower level, programs and algorithms and all this kind of stuff. So uh, the book also just helps you to be able to, think about it in your own way by being able to interpret the text, in English, and then translate that, whether it be in your mind or in, physical notes, into code and into practice problems. Really, really helps that kind of learning click. I'm having to actually read this rather than watching someone else do it and then trying to mimic. There's no mimicking or watching somebody else now. It's completely up to me to be able to understand and interpret what's going on within this paragraph, right? So that independent aspect really helps to, bridge that independent learning, I guess. Anyways, let's continue on here. 297. All right. Illustrate, Iliate, illustrate the execution of the selection sort algorithm on the following input sequence. Oh boy. So the selection sort algorithm on the following input sequence. So remember, if we remember selection sort, oh gosh, which one is selection sort again? No. No. Hold on. Okay, here we go. Selection sort, O of n squared in the worst case. It's big theta n squared, so it's O of n squared bound on both sides. For I from 0 to n minus 1, find the smallest number between I. Find the smallest number between n minus 1. The smallest number with. Okay. Illustrate the execution. So it's just wanting us to show, well, you input this and you're wanting to selection sort. So you would iterate through, find the smallest. Okay, so this is what it would do. All right, in step 1, you would have the array. Okay. Or like in step 0 rather, right? In step 1, we're going to take it'll iterate through the array in linear time, find the minimum, and then move that minimum to the right place, basically, right? So it'll take this. Does it swap elements to the left and right, or does it swap the element that it found with the place it found? Hold on, let me see here. Swap the smallest number with numbers index I. Okay, so it swaps it. So then the 22 will be removed, the 3 will go here, and the 22 will go here. We'll copy this down, make this step 2. We iterate through, we find the 9 goes here, so the 9 gets taken here, and the 15 goes here. Okay, we come down, we iterate through. We find the 10 is the next number. It replaces the 36. We iterate through. 13 is the next number. It replaces the 44. Oh. 13, right? Replaces the 44. We iterate through. The 15 replaces the 36. All right, we iterate through. The 22 stays. Okay, you're fine. You iterate through. Your 36, your 25 comes here. 36. You go through again. Your 29 goes here for your 44. Go through once more. 36. 44, and then it will go through one more time to verify that it is sorted, right? So this will be 4, 5, 6, 7, 8, 9, 10. Right? Same. Using GPT is really good at helping us find solutions without giving us the answers. Bridge the gap of independent learning. Yeah, exactly. Yeah, see, it's just a tool that when you can use it responsibly, it can really open up a lot of doors for you. Now, you you have to have that self-discipline though of being able to, limit the amount of access you give it to, what it shows you. Like, I really like even if it starts to spew on, like I will little scroll on as fast as I can to not try to get a glimpse of it because at the end of the day, like, what does that really help you do? Now, yeah, I get it. Like, you got other classes going on, you got stuff, other things you got to work on. So, I somewhat feel for the whole the computer science major and the people that in college. But if you're independently doing this like me, and you're finding yourself just copying the AI and looking at the AI all the time, really kind of have like an honest conversation with yourself and just say, like, do I want to be reliant on something else completely or someone else completely? Because someone else is making that software, right? Or do I want to be the one to, eventually be able to make that software, right? And so I had that conversation with myself and I said, why would I want that person to, I want to do it. So that's, well, I just, whatever. It's really just about kind of being honest with yourself when it comes to this whole self-learning and being disciplined. If you can't be honest with yourself and you're okay with lying to yourself, then I really don't think you'll get very far. Uh, you know, I kind of have like a personal guilt on honestly when I lie to myself, because I know that I'm lying to myself and that I know. So, you know, if and I'm not tired and I say I'm too tired to come on the stream today, well, I'll know. I just, you know. Anyways, enough of my ramble. Let's move on. Number 9-8 here. All right. Illustrate the execution of the insertion sort algorithm on the insert sequence from the previous problem. Okay. So insertion sort. Okay, insertion sort. We go back to our notes here for insertion sort. Merge sort. So insertion sort was like that LeetCode problem that we did, right? You insert the value into the sorted array that's to the left. So this would be our first iteration. 22 by itself is sorted. So in our next movement down here, the 3 would get taken and placed in front of the 22. Like so. And then in the next iteration, the 9 would get taken and placed in front of the 22. In the next iteration, the 10 In the next iteration, the 13. Oh wait, hold on, I'm dumb. Sorry. That's not insertion sort. We go by the next element after this first one here. So the first element we sort is the 15. My bad. You guys are probably screaming at me. Okay, so we take the 15 of I plus 1, basically. We're not starting from 0 because the 0 is the sorted portion. So we take the 15 and we put it here. And that gets pushed down. Now we're on the 36. We take the 36, it stands as it is. We take the 44, it stands as it is. We take the 10 and we shove it on the top and then move that down. We're on the 3 now. We're on the 3 now. That gets pushed on. Moved. We're on the 9. The 9 gets put here. Removed. We're on the 13. The 13 gets put here. Removed. We're on the 29. Gets put here. Removed. We're on the 25. Gets put here and removed. And then we evaluate one final time. 3, 9, 10, 13, 15, 22, 25, 29, 36. Yep. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's go back and check these ones before we move on. Good job illustrating the selection sort. Let's walk through this step by step and verify your work. In selection sort, at each step, we find the minimum element in the unsorted portion and swap it with the first element in the unsorted portion. Here's the breakdown. In 0, initial array. Step 1, find the minimum, which is 3. Swap it for the first element, 22. Find the minimum in the array again, 9. Swap it with the second element, 15, and so on and so forth. Except for it's 36 when it stopped in your illustration. Step 7. So 3, 6, 9, 36. So what happened here is we had 25. So in this one, we're on 3, 9, 10, 13, 15, 22, 36. The 25 is the next number needs to go here. So are these two, the arrays the exact same? 3, 9, 10, 13, 15, 20. Yeah, so I messed up here somewhere. So I blank, I saw the 3, 9, 10, 13, 15, 22. Hold on. I goofed up this one. So 3, 9, 10, 13 with blank array. Take the 3 and swap with that value, the 22. The 9 gets swapped with the 15. Oh, so this is blank, right? So this is blank, okay. So this is our default here, what we had already. So 1, swap the 3, swap the 9, swap the 10, swap the 13, the 36 days. No. we need to find the next element in our array. So here, 10. What's going on? Okay, so we take the 3, it swaps with the 22. We take a 9 goes here, 15 goes here. 13 goes here. What was that number? 36. 13 goes here. 36 goes here. Um, 15. 44. Oh no, I have a 10. Shoot. Okay, hold on. Messed up again. Oh, I keep messing up, boys. Okay. Okay, I have 15 swaps, so now I have a 10 is my next smallest. 10. 36. Next smallest is 15. No, 13. Jeez. 13. 44. Next smallest, 15 for 36. Next problem, 22. That one stay, that's fine as is. Next one, the 36, it goes there, the 25. Next one, the 29. $44. And lastly, the 36 for the 44. And then a final pass. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 9, 3, 9, 10, 13, 15, 22, 25, 29. Nice job, your illustration. More detail. Smallest. So 15 with 36. Okay, cool. Now we're good. Alright, now let's try this one. Nice job illustrating the execution of insertion sort. Insertion sort works by gradually building up a sorted portion of the array, inserting each element into its correct position within the sorted portion. Here's the correct breakdown. So the 15 goes over, the 36 stays, the 44 stays, the 10 goes in. Stay. 10, 3, 9. Illustration looks great. Sweet. Nice. All right. Woo! Got that one. Nice, Zanob. Looks like you got it here. Number 8, 3, 9, 10, 13, 15, 22, 29. 36, 44, 25. Yeah. Looks like we got the same answers here, Zanob. Awesome. Sweet. Okay, let's go ahead and let's shift focus here out of the book. What's the next chapter here? Maps, hash tables, and skip lists. Oh boy. This one is about 50 pages as well. Woo. We'll get into that one. We'll get into that one soon. Okay. Sweet. Let's go. Let's throw these into chapter 9. Sweet. Let's save this up, and then we can exit out of here. Let's open up the Small Business Manager. All right, let's code up the Small Business Manager here, yeah? I kind of want to work on this for a little bit. Let me check to see where my girlfriend's at real quick. Okay, we got some time. You want to do leak code? Oh boy, I was trying to avoid that. Leak code. Well, we're kind of already we're running out of easy problems to do on here. Merge two sorted lists. You're given two heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted linked list and return the head of the new sorted linked list. The new list should be made up of nodes in list 1 and list 2. Okay, so this just... Recommended time and space is you should aim for a solution with O of n plus m time, where n is the length of list 1 and m is the length of list 2. So you have to iterate over both. Okay. So let's think about this. So let's say you have, in red here, you have A, or you have, like he has here, 1 that points to 2 that points to 4. Okay, and then in blue you have a 1 that points to 3 that points to 5. Okay, so can I go like this? Can I iterate using 4i for this guy, and then can I go 4j in this guy, you know, multiplying these basically, well, this is O of n plus m. Not O of n times m. So two unnested for loops will be addition, right? Yeah. So two linear searches in addition. Okay. So then can we just evaluate at each point, right? So you have j 0, 1, 2. You have I 0, 1, 2, right? So can we go like this? Can we say, okay, we're on this value and on this value? Is the I if the I is less than the j, then move the I to here and point it like this. And set the pointer there like so. But how can we insert into there? We're given a head. This becomes the new head. So if we're starting at the head, how can we get access to the one behind it? Well, so I don't think we can put it behind it. So we'd have to say if I is the one in I, index I is greater than here, that this one has to get pushed as the pointer for there. else if it's less than, this one gets pushed here. Okay, so you just have to do the just push it inverse if it's less than. So if I is greater than, it gets put here. If j is greater than, it gets put there. Okay. And then O of one space. Right? So let's see here. Let's say here. Let me bring this over here. I'm running out of space. Okay, so if you say for I in, if you say n equals the range of list 1 for I in the, sorry, not range, length range of n, right? And then we'll also say okay, so wait. No, we won't iterate. So while are they of the same two? Are they always the same length? Are they always the same length? I have fully completed. Nice, dude. So if we build, we return an array back of the head node. One sorted linked list, and I turn ahead of a new sorted linked list. So are they linked though, or they just get indexed? Okay, so the thing I'm trying to figure out is every example he gives always the same? The length of each list is within this bound. And it's only the list 2, so maybe they're not. If different variables, they probably could have different lengths. This is the second experience watching your channel. Awesome, we're in sync here. So do we want to, for either range, this is the length of here. Let me say because we need to do these at the same time for each node. But these aren't lists though, they're linked lists. So we should be calling dot next because we have a node here, which is a list of nodes. So are we supposed to be return the head of the new sorted linked list. And return the head of the new sorted linked list. Why is this outputting the whole list then? Merge the two lists into one sorted linked list and return the head of the new sorted linked list. Why is this outputting the entire sorted linked list then? As the example. Are we returning a list back, or are we returning a linked list back? Like, am I supposed to be going while node.next, while node does not equal none? Right? Or am I supposed to be iterating over an array? An O of n plus m, though. So the thing is, though, is you can't... So we have to nest these, though. So for j in the range of m, whereas m is equal to the length of list 2, right? We're going to evaluate if list 1 index I is greater than list 2 index j, well, what do we need to account for, like, if these nodes are none, though, right? Because j, they could have different lengths if list 1 is none. Right, exactly. So we'll say I is equal to 0 while list 1 index I dot does not equal to none, right? So if n is then equal to 0, return list 2. Oh, weird. Oh, shoot, I suck at linked list. So, while the list 1 index 0 does not equal to none, so while so if that happens, okay, so that'll cover that as well, because none will be there in an empty array. But what if, God. Okay, so if we need a statement here then to say if n equals to 0, if n is equal to 0, meaning this length is none, and m is greater than 0, return list 2, elif n is greater than 0 and m is equal to 0, return list 1, right? Else what if they're both equal to 0? So we'll make this an elif then. If n is equal to 0 and m is equal to 0, return just an empty array. Return array. So we'll say array is equal to here, like this. Link. So we need to build a linked list here. So O1 space though, so we shouldn't be using another array. So we need to utilize the current arrays that we have. Not create any more memory places. Okay, so this will just return a blank array, like so. Okay, so else can you just add the list together? That'll combine them just in that order, but we're trying to keep them in the sorted order that they're wanting, right? So what if we pop every value? How can I, the thing is though, is how can you iterate simultaneously across both of these lists if they have differing lengths? Because we're not O of n times n time here. We're O of n plus m. So we're so while list 1 index I does not equal to none, right? Yeah, it wants us to, well, I'm not sure if we can only use one for loop, but yeah, we don't want to do that either. We don't want to append into one list and sort. I mean, because that's not the recommended time either, right? That's a brute force way. It's still, if you use two separate loops. I mean, yes. So the thing is, though, is I need to access and evaluate them at the same, within the same loop, though. So I have to nest them while list to index I is not equal to none. So this is going to be node, left node is equal to list 1 index I, right node equal to list 2 index I, I need to evaluate these two nodes. So while list 2 index I is equal to none, right node, if left node dot val is less than your right node val. Node dot val. Right, if it's less than the right node dot val, we want to put oh shoot. I found with Python syntax. What is list 1I? The ith node. Yeah. Yeah. So if the left node has a value that's less than the right node, we need to take the right node and make it its temp is equal to node dot next. So then left node next equal to right node. shoot. 1, 1, 2, 3, 5, 5. Am I on the right path here? I feel like I'm not. Hit 1. Improve for something. I already know that. That's what we're already trying. That didn't helpful at all. So what if I pop values off? Wow. Okay, what about this? While length, while list 1 is greater than 0, if list 2 list list 1 dot pop left node equals that. If list 2, which we should have list 2. Alright. So then I don't even think we need this. If list 2 right node equal to list 2 dot pop if left node less than node right if the left node So while we have nodes while the length of the list 1, right? Okay, so this is what I'm doing here. Right, so while the length of the list is greater than 0, left node is equal to, we'll pop off the last node. Okay, so in my example here, we're doing this. Okay, so we're popping off the 4 and the 5, evaluating. Okay, the 4 is less than, so we said the 4 is next to the 5, and those are gone now. Okay, so now this is our linked list. Right, and then we're here. We pop off 2 and 3. We evaluate. Okay, 2 is less than 3, So we set 2's pointer to 3 and set this to point at the previous one. And then we do the same thing for this guy. Right? That's what I'm trying to do here. What do you guys think about that? Right, you pop out the 1 and do 1, 1. So while list I, list 1 dot next, not, or list 1 index I not equal to none, right? Hey Shin, welcome. Yeah, we're trying here. So while the list 1 index I, so we'll have to set I is equal to 0 here, is equal to none, is not equal to none. Okay, we're going to pop off a value. No, I like my other approach. Hold on. So what if I did take lengthless 1 is greater than 0, pop off a value if the left node is greater than, left node dot next is equal to right node. So we have an array here. We return the head. So we just return the head then. Okay. Else elif left node is greater than right node value, right? See, why am I getting this dot next highlighted here? Is not val. So if the value my question is, guys, is are these lists always the same length? Right? Like that's what I'm like, because that's what I'm confused on is what happens if they have different lengths, then one falls short than the other. So in this case they're the same length, but in this one they're not. So we do have cases where they're not the same length actually. Okay, so shoot. So then we have to say while list 1 how do we get access to the node? List 1 is a list of nodes. Index we need a starting node, right? Right. So while start node does not equal to none, Um, if list 2, right? Well, I kind of want to pop off values. Start here. Right? Like, what happened? Can we, what if we just pop off values and work from the back? Like, if we pop off, in this case, we pop off the 4 and the 5, we evaluate them, and we set their assignment. Then we pop off the 2 and the 3, we evaluate them, set their assignment, and then assign that to the assignment of those. And then we pop off those, and then do the same there. But that would require them to have the same length. So while start node does not equal to none, if list 2, meaning if you have values within list 2, so we need a start for each list. Start node list 2, list 1. While start node list 1 does not equal to none, while start node list 2 does not equal to none. So in this one, we're going to get the node. So okay, so are we on the right track here then? Okay, so while start node list 1 is unequal to none, and so we can get the value here. If we enter this loop, okay, we have a value for start node list 1, which is list 0, which is equal to list 2 index 0, right? So we'll evaluate these two nodes. Then we need to have a head is equal to none. No. Oh, shoot. So while the start node, I just am not sure about these nested loops because we're gonna grab one. Okay, and then we're gonna, oh, we don't have one, so we don't need to. Okay, so oh, dang it. I wish they tell you, well, I'm kind of inferring that they have different lengths by this example here, right? They definitely do, right? So should we go to tip 2? Create a dummy node to keep track of the head. So you do keep a dummy head node. With a head. Wow, head. Start node list one. So said to resulting list. Well, iterating through the lists using L1 and L2 as iterators for list 1 and list 2. Okay. If so we're in here. If start node so it's less than or equal to. We'll handle that case here. Else it's the inverse, so we need to head and dot next equals start node list 2. Start node list 2 dot next equals start node list 1. And then we update we break out of this loop and we update both of them. Oh shoot. I must have linked on this one. What's inside? So while the node does not equal none, and while start node list 2 does not equal none, if start node list 1 dot next is less than or equal to start node list 2 dot next, we take the head node and sign the list 1 head next to it, and then sign that next to this list 2 node. And then at this point in time, we need to break out of this loop. you need to determine which one is larger, basically, which array has a larger length. Because the larger length one is the one we need to iterate over, right? In its entirety, because we're going to have basically another loop to loop over the entirety. Well, that doesn't make sense though, because okay, so we want to at least loop over though we want to at least, we have to loop over the range of n plus m. Right? Because that will at least get us the maximum amount of loops needed to handle the maximum number of cases, which is in the worst case, O of m plus m. So while this, we break, we break here, and then we also break here, and we update and then in our for loop, within our for loop still, so within our for loop still, we will update start node list 1 equals start node list 1 dot next, and we'll update this the same for this guy. Now the thing is though, if start node, so then we don't need even all this crap up front here, except for this part here. Oh, right? We just need to go like this and say, we need to check here and say if start node list 2 is equal to none, we're going to go oh shoot, we don't want it. Oh no. No, Brian, we did not. We did not solve the valid Sudoku yet. Hey, Jaws, how's it going? Welcome back. So for, right, while We won't nest this necessarily. But we have to nest them because we need to do an evaluation. So if start node, this 2 at this case is none, because this won't even enter start node 1. So if Hey Armando, why does the title say teaching myself Python? Looks like you already know you're doing how many years you've been coding. Well, funny enough, we've only been coding, full time, I guess, every single day for the past 2.5 months. But I've been learning for just about 6 months now. I started completely from scratch. I had never seen a line of code, never written a line of code, never even seen a function, hello world, nothing. About 6 months ago, the beginning of the summer 2024, and this is where we are now. So we have come a long way. So this just goes to show you that this practice and this everyday learning that we're doing is working now, and we are struggling through this problem here. But you know, not sure if you can do length for a node. Why would I call length on a node if a node only has a val and a next? Jaws. But I appreciate that. I'll take that as a compliment, Armando. If you think I'm not a beginner, if I don't mimic a beginner here, only 6 months in, then I'll take that as a compliment. Thank you. Should I take that as a compliment? So we have to iterate over the entirety of the range. If oh, 9, 10, and 11 here. Oh, I'm taking the length of a list. So it's a list of nodes. Easy +1 compliment. Thank you so much. That's what's up. So 6 months I could potentially be this good. That's awesome. Yeah. So I have a Discord link below. I have documented my entire progress via visually through this stream and also through text in my Discord. So I provide weekly thread updates for all of the courses I do for CS50X. Every time I finish a week, I provide an update of all the things I learned, the links to all my notes, the links to my solutions, the links to the stream that I did it in, the links to the problems I did it in the stream. I have it all in those weekly thread posts detailed. So if you want to and if this is something that you are aspiring to be and want to follow a similar footsteps as me, not saying that I'm doing this in a correct way, but just from raw learning, I feel like I am picking this up, sort of. Um, I am, outlining it all for you guys as best I can in the Discord and on the stream here, completely transparent, completely free. So, all I ask is that you kind of, support along and just throw a thumbs up every once in a while on the stream and, follow along and subscribe. I do have put in a lot of hours of just work, off outline on the Discord, the stream, the YouTube videos, editing, and in addition to just the studying as well. So it's been like more of a getting the whole platform together is oh, it's a single node, which is the head of a linked list. Oh, really? So I'm not just understanding. You are given the heads of two sorted linked lists, list one and list two. Oh. Oh. Okay. Okay, so I thought these were lists, then they're not. They're heads, they are nodes. Okay. So then we can't do this. And then we can't do this either. Shoot. Okay, now we're back to just square one then, I guess. It's okay. Okay, so let's think here. We want to merge these two linked lists together, right? And we're given the head of a linked list. So while list one dot next is not equal to none. Okay. No, not dot next. So while if list one equal to none, return list two. If list two equal to none, return list one. Else while list one is not equal none. Oh shoot. Chapter 8 Python Crash Course. Let's go. Oh, which one's chapter 8? Is that files? Classes is 9. Oh, you're almost to classes. That's a fun one. Functions, chapter 8. Oh, you're getting into the meat of it here, Carlos. Chapter 8 and chapter 9, you'll really start to kind of understand, like, it really starts to open your mind about what you can start to do by creating functions and then by classes, especially. When I learned about classes, like, oh, finally, here we go. This is what I've been wanting to figure out, is how can I represent stuff. So if list 1 is none, elif list 2 is none, return this. Right, else, while list 1 does not equal to none, right, else head is equal to list node, while list 1 is not equal to head. Dang it. Why am I struggling? We create a dummy node to keep track of the head of the resulting linked list while iterating through the lists. Using L1 and L2 as iterators, we traverse both lists node by node to build the final linked list that is also sorted. So while the list 1 is not equal to none, right? This gives us access to the first node in our linked list. We then need to get the second node. Oh, sorry. You're right. Turn list one. Right, so head. So then if we while list 2 does not equal to none, if list 1 dot val is less than list 2 dot val, but what if we're going to grab a left list and grab a right list? If not list 2. So I'm confused about the case for when the one list runs out first. That's what I'm confused on. I don't know why it's really giving me a struggle here. So while the list 1 does not equal to none, we can grab the head. We're on list 1, which is the head node of list 1. Right. We say here, if not list 2, head dot append list 1. If not list 2, head dot append, no, head dot next equals list 1. List 1 is equal to head. List 1 equals list 1 dot next. So we need to set the head node to the new value. This one is equal to head. So head becomes list 1. And list 1 becomes list 1 dot next. While list 2, if list 1 value is less than list 1, if list 1 value is less than list 2 value, I don't know if this helps at all. Did you paste something in, Ribbon? I don't see anything if you did. Okay, let's go to hint 3 here. For example, consider list this. We move pointers by comparing the node values from both lists. We link the next pointer to the iterator. When List one is the one. Proceed. Yeah, that's what I thought. So hold on, you guys. I'm really having trouble. Like, are we supposed to nest these loops? Because like, if list one is empty, runs out first, I won't even be able to get to list two, right? So do we need to have like loops like this all nested within like a while true to basically handle like a constant main loop over these sub loops? We are supposed to have nested loops. Like while true. Wow, this one and I don't know why this is tripping me up so bad. Anybody have any pointers? Let me check something here. Well, I hate to bail on you guys, but I've got to go. My girlfriend's coming home, and it's coming up on 10 o'clock here. Dang, I'm super disappointed we weren't able to solve this one. I mean, I feel like I know the concept. I know how to do the pointer adjusting and push in, merge in new things into pointers. While list one does not equal to list two, that will pointers. Yeah, I've got two. All right, you guys, I've got to call it here a little bit short for today. Well, not short. We did do 2 hours, but I did start a little bit late. Unfortunately, we weren't able to finish this one yesterday, but we will come back and try this one again tomorrow. I'll think about this one a little bit over the evening tonight. Um, but please join the Discord link below where you can get access to all my study resources. And Michael Collins sick and chill with us. I wish. But for those that are new, I do have a 9 to 5 job. When we get both, when they both get to none. Oh, I see what you're saying. So, oh, that's how you do it. Okay, so in one overarching loop, you do it until in both of them don't get to none. Okay. Okay, I'm gonna think about that now. Okay, you guys, thanks so much for joining me. I'll be back tomorrow, 7 p.m. PST. I'll announce it in the Discord. Sorry about the the struggle through this one, but sometimes it just that is the reality of this studying. I appreciate you for joining me. Um, yeah, this one is a little bit harder than I had initially thought. So we'll come back and try this one again, either tomorrow or I might come back a little bit later this evening and give it another go. But I'll let you guys know what I decide in the Discord. Thanks so much for joining me. I code for about 2.5, usually about 2.5 to 3 hours every single day. Doing these live problem solving, reading out of books, other courses. But I work as a chemist. I have a degree in human biology and a minor in chemistry. I graduated back in 2021, and I work as a formulation chemist for a biotech company. So thank you guys so much for joining me here. I will see you guys soon. Um, Anywho, I will talk to you guys in a bit. Just making sure. All right, yeah, I gotta go help my girlfriend bring her bags in. All right, guys, see you guys tomorrow. Make sure to subscribe so we can see each other tomorrow. I love hanging out with you.